So today we're going to start off with a pretty simple topic, and that is classifying triangles. And you already know a lot about classifying triangles that you may not even have realized was a thing. So we classify triangles in two ways. We use angles, what kind of angles the triangle has, and we also use the side lengths. So we're going to do that today. We're going to classify triangles, sort them into the correct category, and then we're also going to use that information to solve some simple problems about triangles. I would ask that you make some notes on this while you watch the video. So you can see by this graphic that there are classifying the triangles by their angle measures, and there are four different types of triangles that we talk about. The acute triangle, which is the first one, has all three angles are acute angles, and by acute we mean angles that are less than 90 degrees. We can see that the second triangle that we're looking at here is called an equiangular triangle. And equi would be equal, and angular means angles. So equiangular triangles are triangles where all three angles are the same measure. And we know because the triangle has a total measure of 180 degrees, if we divide by 3, each angle is going to be 60 degrees. So all three angles in this triangle, this one, and this one, are all each 60 degrees. Turns out that this is also would be an equilateral triangle, which is another term we're going to use when we classify it by side length. So if all the angles are the same measure, all the sides are also going to be the same length. And we have talked about triangles like this. If you think back to when we were using Heron's formula and we were investigating regular octagons, those triangles we were looking at were equiangular triangles. Then we can see a triangle that we're very familiar with, right triangles. And of course, a right triangle has one 90-degree angle. And there it is. We designate it with that little square in the corner. The last type of triangle is an obtuse triangle, and an obtuse triangle has one angle that is greater than 90 degrees. So those are our four kinds of triangles. All right, so you can see here we have a triangle. It's named EHG, and there it is, triangle EHG, and it asks us to classify it by its angle measures. And we can see here that we have degree measures of 30 degrees, 60 degrees, and 90 degrees. And based on that, we're going to call that, the best name for that is because it's not all acute angles, it's got that 90-degree angle, we're going to call this a right triangle. So that's its classification. Okay, the next triangle we're going to look at is the triangle that is over to the left side of this picture. And let's use a different color for that. Maybe we can use red. And so here we have triangle EFH. And we can see here that we have an angle that's 30 and another angle that's 30. And we have this third angle here. And we know that because it is a triangle, that the total angle measure is 180. If we subtract 30 plus 30, which is 60, we're going to get 120 degrees for this angle. So this is clearly greater than 90, so this would be an obtuse triangle. So there we have. We've classified two triangles, and we'll ask you to do a few at the end of this lesson. So the other way, as we mentioned earlier, to classify triangles is by using their side length. And you can see in the graphic on this slide that there are three types that we're going to talk about. One is equilateral, and you can see the very first one is equilateral, and so all three sides are the same length, which is marked. They're marked as congruent with these little tick marks. Then the next type is the isosceles, and you can see the middle example is an isosceles triangle, and that has at least two congruent sides. So the very first one we looked at, an equilateral triangle, is also an isosceles triangle, but it's got a more exact name, equilateral, because not only two sides are congruent, but all three. So an isosceles triangle has at least two sides that are the same length. And you can see in this example, there are two sides that are the same length, and the third side looks to be shorter. The third type of triangle is, of course, one that is neither equilateral or isosceles. It's a scalene triangle. And a scalene triangle means that there are no sides that are congruent. Scalene triangles have no sides that are the same. So if we were going to use tick marks to mark this, we'd put 1 here, maybe 2 here, and 3 here, showing that all three sides had different lengths. So here we have an example of some triangles we want to identify, or classify rather, by their side lengths. And the first one we're going to look at is triangle ABC. And we can see that triangle ABC has these two tick marks, meaning that both of these sides have measures of 15, because one has 15, the other one is also 15. And then if we look at the third side down below, that is also 15. So although this triangle is isosceles, the better name for it would be equilateral. So we're going to name this as an equilateral triangle. All right. The other triangle we're going to look at is triangle ABD. And so if we look at triangle ABD, so here's ABD, we can see that it has one side that's 15, one side that's 18, and then the third side, BD, using the segment addition postulate, we're going to have 15 plus 5, so this side is going to be 20. And so we have three sides, 15, 18, and 20. They are all different. It has no congruent sides, so we're going to name this a scalene triangle. And that's the word you're probably least familiar with, so that's the one to focus on. So here we have a triangle, and it has algebraic expressions for each side. And we're instructed to find the value of x, and then what are the side lengths for all three sides. So the key here is to notice that this side and this side are congruent. So we have an isosceles triangle. Therefore, we can set up this equation x plus 3.2 is equal to 4x minus 1.3. And then just use our algebra moves. So if I subtract x from each side, I have 3.2 equals 3x minus 1.3. If I add 1.3 to each side, then I'm going to have 4.5 equals 3x. And then we divide by 3. And I know 45 divided by 3 is 15, so 4.5 divided by 3 is 1.5. And so x is going to be 1.5. So I did the first part of it. Now I have to find the side lengths. Really, there's only two places I need to do that because two of the sides are the same. So the first place I'll do it is here. I'll say 1.5 plus 3.2. And 1.5 plus 3.2 is going to give me 4.7. So I know that LK is 4.7 in measure. Notice we did not put the segment bar over the top because we're talking about distance or length. And also JK, which is congruent to that, is also 4.7. And then we have to find the third side, which is the 5x minus 2. So if I take 5 times 1.5 and then I subtract 0.2, I will have the length JL. And 5 times 1.5, 5 times 15 is going to be 75. So this is 7.5 minus 0.2, and this would be 7.3. And so we have a length of JL is equal to 7.3. And there we did it. We have all three sides of the triangle, the lengths, and we knew what x is. Okay, the last example we're going to do is an application problem. And we can see here that we have a little triangle like you would ring in music class, and it has 4 inches on each of the 3 sides. Now, unlike a triangle we draw for geometry, this has little curves in it, so it's not going to be, it's going to have some error in this calculation because it's not a perfect triangle. But we're going to, there's always some assumptions in mathematics, in applications, and it'll be close. So the manufacturer produces musical triangles by bending pieces of steel to make this triangle shape, an equilateral triangle. And the triangles are available in side lengths of 4, 7, and 10 inches. And we're going to concentrate on the 4-inch sides. So if we have a 100-inch piece of steel, and I want to know how many of these 4-inch triangles I can make. Well, I have 3 sides, so it's 4 inches plus 4 inches plus 4 inches, which of course is 12 inches. So what I need to do is figure out how many times 12 can go into 100. And I know that 9 times that would be 108, so this is going to be 8 times. And 8 times is going to be 96. And then I'll have 4 left over. So I don't really care about that leftover bit because I'm not going to make part of a triangle. So the answer for this would be that we can make 8 of those triangles from that piece of steel. All right. So here are 4 problems for you to try yourself. And the answers will be at the end of this presentation. So I would pause the video here and solve them and then check your work.